We begin our journey at the break of dawn, standing before a vast landscape of discarded aluminum, where the cycle of rebirth is about to commence. These ordinary remnants of daily life, once thought of as waste, are gathered here to be transformed into something far more sophisticated and incredibly precise. The mechanical claw grips the mountain of metal, initiating a process that will strip away the old identity of these cons and prepare them for transformation. As the conveyor moves forward, the chaotic jumble of scrap metal is fed into the shredder, breaking down the large pieces into uniform, manageable metallic fragments. The shredding process creates a metallic rain of aluminum flakes, each one cleaned and prepared to face the extreme heat that will soon change its state. Purity is paramount in this process. Powerful magnets work tirelessly to extract every trace of iron and steel, ensuring only high-quality aluminum moves toward the furnace. We transition from the cold scrap yard into the heart of the foundry, where the air vibrates with the intense heat of the industrial melting furnace. The heavy furnace doors yield to the internal pressure, revealing a core of pure energy that will soon turn solid metal into a glowing liquid river. With temperatures reaching over 700 degrees, the shredded aluminum is introduced to the molten bath, where it dissolves instantly into a swirling orange vortex. Observe the intense transformation as the metal reaches its melting point, becoming a fluid energy source ready to be refined into a high-performance industrial alloy. The refining process begins with the removal of dross, as a mechanical tool skims the surface to discard impurities, revealing the pure silver liquid underneath. What remains is a clean, molten base, and the blank slate of aluminum that will now be enhanced with specific elements to meet rigorous mechanical standards. Precise amounts of magnesium and silicon are added to the mix, creating a specialized alloy that offers the perfect balance of strength and lightweight performance. This chemical alchemy happens in seconds as the solid elements fuse with the molten aluminum, changing its molecular structure for the demanding tasks that lie ahead. Every degree matters. The temperature is monitored with extreme precision to ensure the alloy remains consistent and ready for the critical process of continuous casting. The furnace tilts, releasing a steady stream of liquid silver into the casting channels, marking the transition from liquid state back into a solid. The flow is mesmerizing, a river of fire that moves with purpose toward the molds that will give it its first structured shape as an ingot. Entering the vertical casting station, the liquid metal is contained within long molds, where it will undergo a rapid cooling process to form solid billets. Sudden cooling is achieved through the high-pressure water spray, a violent yet controlled reaction that causes the aluminum to solidify into a dense, crystalline structure. Steam clouds the air as the thermal energy is stripped away, leaving behind solid pillars of pure aluminum alloy, ready for the next stage of manufacturing. As the heat dissipates, the metal reveals its true color, a brilliant, clean silver that signifies the success of the refining and casting phases of production. The industrial robots take over, lifting the heavy, solid billets with effortless grace, showcasing the synergy between raw materials and high-tech automated handling systems. Stacked and ready, these billets represent the physical manifestation of recycled value, now possessing the perfect metallurgical properties required for high-precision machining and engineering. The billets are transported into the machining center, leaving the heat of the foundry behind to enter a world of micron-level precision and robotic cutting. Before the first cut is made, a final inspection ensures the material is flawless, guaranteeing that the final component will meet the highest industry standards. Inside the CNC enclosure, the environment is sterile and focused, where a piece of the recycled billet is prepared for its ultimate mechanical destiny. The spindle roars to life, spinning a carbide cutter at incredible speeds, preparing to carve through the aluminum with surgical accuracy and relentless power. As the tool makes contact, the silence is broken by the sound of high-speed cutting as the first layers of metal are stripped away with ease. Moving in 5 axes simultaneously, yet the machine follows a digital blueprint, translating complex computer-aided designs into physical reality with every pass of the tool. The waste produced here is beautiful in its own right, delicate silver spirals that will eventually be collected and sent back to the start of the cycle. A constant flood of coolant keeps the temperature stable, protecting the integrity of the metal and the tool, ensuring the finished surface is flawlessly smooth. In slow motion, the violence of the cutting process is revealed as a controlled dance of liquid, light, and the relentless force of the carbide edge. Smaller tools now enter the frame, drilling precision holes that are accurate to within microns, providing the necessary pathways for the component's future assembly. Complex cooling fins emerge from the solid block, showcasing the incredible versatility of aluminum and the power of modern computer numerical control machining technology. The machine changes its own tools in a matter of seconds, switching from heavy material removal to the delicate finishing work required for the final details. A fine-pointed tool traces the final contours, adding a sophisticated texture that enhances both the aesthetic appeal and the functional performance of the recycled component. The final pass is complete. The surface reflects a level of precision that was once impossible, proving that recycled aluminum is equal to its virgin counterparts. The machining cycle concludes, and the enclosure opens to reveal a masterpiece of mechanical engineering, born from the scrapyard and forged in fire. A blast of air clears away the remnants of the process, unveiling the gleaming silver surface of a part that is now ready for inspection and service. From a crushed can to a high-precision component, the journey of this aluminum is nearly complete, having undergone a total physical and functional transformation.
We've achieved
quality control is the final hurdle, and every dimension is measured to the thousandth of a millimeter to ensure absolute compatibility with the high-performance assembly. Automated probes map the entire geometry of the part, verifying its complex curves and holes against the original digital design with uncompromising robotic accuracy. The result is a masterpiece of modern industry, a precision component that is lightweight, durable, and sustainable, ready to take its place in the world. Carefully packaged and labeled, this component will now head to its final destination, serving its purpose until the day it is ready to be recycled again. This is the eternal cycle of aluminum and metal, reborn through technology and fire, proving that in the world of engineering, nothing is ever truly wasted.
The structural integrity is holding at 98%.
Reroute auxiliary power to the stabilization matrix.